Hello everyone. So in this example today, I'm going to be showing you how the TimelinePI process intelligence tool can be used within various process areas in government. So we'll be using data from three different types of processes. The first you're going to see is City 311 services, and specifically how the request gets fulfilled through the city departments. And the main data source we're pulling from here is known as a 311 call center, which you may or may not be familiar with, but is a widely used system for non-emergency and city service requests for city and local governments. I'm going to be going from tab to tab here. The software is online, so it's a software as a service. You can get it on the web. The second project you're going to see is data invoice processing, going through that, and that's going to be coming from an ERP system for invoice processing. The third data set is emergency response. This data set is in relation to emergency response, in particular data from fire and EMS CAD or computer-aided dispatch systems. So as I move from one project to another, demonstrating the use of the TimelinePI tool on these various process areas, the analysis modules you're going to see are universal. The TimelinePI engine itself doesn't know anything about the service request, invoice processing, or emergency response. So the analysis that you see that we shape could just as easily be done with any other industry verticals, including but not limited to applications, insurance, logistics, sales, or of course, like we're going to see, invoice data. So it's totally agnostic to the industry. The idea throughout is to give users a much better understanding of what's going on in the business process, no matter what type of vertical is being supported throughout. So to start us off, I'm going to load some data. It's going to be coming from a simple CSV file for city services data. I reach out to that. Understand that once these systems are implemented, we have background tools where uploads could be scheduled and kind of could be automatic in the background, so you don't have to worry about how the data gets into the tool. Today we're simply going to load the CSV file, show you how to map the different headers, and then go in and show some of the analysis. So it's worth mentioning that the timelines can be assembled from multiple files. So this is going to correspond to different systems of record, or different events come from different sources. As long as they have the same object identifier, we connect them together. So there are just three fields which are required to get started with the TimelinePI tool, and they're here in orange. So the first, you'd want a time field. The timestamp, it's simply going to tell you when an event happened. And then next, you want a timeline ID, or an ID field, which allows you to join all the events in a given process instance into the same context. So think of this as a customer ID, a citizen claim, or an invoice or a service ticket number, any type of unique identifier which signifies what we are looking to measure. And then lastly, the event name. So here we have a lot of nice event names such as issue reported, case open. Some systems will have these coded and different things, but as long as you have unique events such as the request is submitted, works completed, or a claim was submitted by a customer or an inspector assigned, those are the only three required fields we'll need. So lastly, we can also bring in additional fields. Those are things you're going to see like the department, problem, comments, unit ID, all these other dimensions and attributes that we have along the lines there. So that's going to be the way that we can use this to form a type of breakdown, ways to slice and dice the data by. So this here is simply a drag and drop interface. While you're mapping, you can see you can drag these headers over to map your data. The only thing, like I said, the three required fields need to be filled. These other dimensions could be blank, as you see. So when I would finish doing this, once we map some of these columns in the file, we now simply hit the load, confirm, and start the upload. What that would do then is begin reconstructing the process based on these events. But I've already loaded the data for this demo, so I won't waste the time doing that. But if I had loaded it, the data would have taken about 75 seconds to load what we have, which is about 305,000 events related to non-emergency service requests. So in that time, the tool will reverse engineer the process, build out all these models, and create multiple forms of analysis. Immediately upon loading the data, we're then presented with this overview page, which includes quite a few metrics we're going to give us a better understanding about our project and the data we've uploaded. So right out of the box, you're going to be able to see some of these things such as how many different events we have within this data set. So this has pulled out 16 different events. It's identified how many times they occur within the data set, how many timelines or how many service requests these events occur on. Aside from that, we see that there's nearly 305,000 loaded events, created and mapped to nearly 29,000 individual service requests, and we have a data time range of 174 days. Aside from that, right off the bat, loading the data, we begin to see some of the process areas that we might want to identify where there might be problems. So of course, the first event, 91% of the time we see that the issue reported makes sense with the city service request, that such a thing like a pothole was reported to the city government, departments are assigned, etc. What we're seeing is nearly less than 1% of the time is when a case is closed as the first event. That's certainly abnormal in a way that we may be able to begin to drill in on and identify some of these problem areas. Aside from that, we also see some of these last events, things that you wouldn't expect, such as less than 1% of work inspections approved. We're beginning to see that right out of the box. I also want to bring your attention to this left panel and the top bar here. So these are things that are going to follow us along throughout the project as we drill in and scope our analysis. So whatever data set or whatever unique timelines you're looking at, you're going to see the duration, the number of events on those timelines, even some of the cost breakdown for how long or how much that process is costing, the total as well as the average cost. And again, as you scope the analysis, you'll be able to see the first event and last event as you drill in and become more familiar with the project and drill in on problem areas. So all of these is the current set we're looking at, the full project set. I want to drill in and look at some of our timelines. And this is the area where I want to define sort of what we're dealing with. So it's really a part of our name, TimelinePI. A timeline is simply just the history of a process instance. So think of anything like a sales order, an invoice, or an insurance claim, any of these sorts of things. This is what a timeline consists of. So a timeline simply consists of events which state that something happened at a specific time. So each of the different lines that you're looking at with the circles on them represents a different encounter. So each of these lines is an individual city service request. Each circle represents an event or step in the process. So as you go along, you can start to see where there might be areas where there's problems. The length of each timeline is proportionate to the elapsed time. So of course, some are going to be longer than others, and this includes gaps where steps where nothing has happened. So we'll start to see areas where there's an example of a bottleneck may be occurring or process efficiency can be improved. So if I scroll through here, I can see that no two timelines are very much alike, but I can drill in and begin to analyze further in any process instance and begin to see exactly how these are breaking out and what's happening. So when you think about understanding the end-to-end process from start to finish, this is a great way to do that. So this screen here is showing me details specific to timeline number X or the city service request number X. So along the left, you're going to see all the events which occurred as a part of this specific service request, but also as we get further and further into a deeper analysis and some of these sub-processes begin to break out. So what the tool is doing is it's automatically detected steps in the process or events in the process which are done as sub-processes or parallel processes, and has grouped them together. So you're going to see here, for example, every request should have an issue reported and then a case opened, but not everyone is going to have an issue inspector assigned or an issue found. So what the tool has done is automatically shown that these are areas that commonly occur together, but not in every case. So if you think about loading up data from multiple systems, different departments, this is the place where we are essentially pulling together the composite life cycle of this service request, end-to-end, understanding the process of 311 to the completion of work and resolving the issue and closing the case. So regardless of the system of record which is responsible for recording these events, this is the area where this entire end-to-end process can be viewed. So in scrolling through this list of all the different individual city service requests, we see that there's a huge amount of variability in this process. Having looked through this data, I can tell you that there are no two timelines that are exactly the same. So you might ask if there's a way to map a process diagram. With my experience in city government, this is a question that a lot of business users struggle to answer with their existing technology. And it's a big reason why users can't tell you with a high amount of confidence exactly how their processes are being executed. So I want to bring your attention to our process schema tool. And this is a way to give you the capability to visually map the most common path through the process. So we can see that I have one saved here from earlier, but I just want to demonstrate for you how quickly and easily it is to start a new schema and be able to visualize your process here. So as I initialize a new schema, I'm going to select the default milestones and allow the tool to generate its default schema. So what I see here is, of course, what looks like a process path, but it's rather simple. It doesn't really tell me much about my process. So I'm going to go in and change that and actually bring in more milestones, more events, and I'm going to leave out where citation is issued. And imagine where a citation is issued, where a fine gets issued or something of those sorts. Now I generate that and I can see a much more in-depth kind of process analysis. It looks a lot like a Visio diagram showing me my different events and how the process flows. But I want to let you know this isn't a Visio diagram. I can save this as anything I want, and then this becomes a monitoring tool to understand better how the process is flowing. I can then also play this and see all of my events and the service requests being fulfilled through this process schema. So by allowing this to kind of go through, I can start to see some of the timeline aging, start to see where there may be some bottlenecks, certainly these areas where things are getting tied up, and drill in on those. If I pause this and I see that some of these are taking longer as the timelines age, I can drill in on any of those, bringing up this instance again, seeing how workflow is being broken out, seeing how the process is flowing. So this is certainly an area where when you're thinking about where this type of functionality could be useful, first and foremost, it's just getting a better understanding of the existing workflow, certainly identifying where bottlenecks may occur, but also we can actually identify some areas where location of milestones. So I don't want to forget exactly where that issue, the citation gets issued. So I'll find that out. So I can statistically find out exactly where those are happening 56% of the time before work to fix is scheduled, 7% of the time before work is completed, and 38% of the time before case is closed. So you can find the location of an event, the likelihood for that to occur, anywhere within the process. So as you see here, these timelines, as they go through, the thickness of the lines here are going to show the number of transitions, so you can see how many of these service requests are flowing through there. You can also see the time length of the transition. So by then showing where, of course, where these bottlenecks may be occurring, how long it's taking between those sorts of things here. So now that we have a much better understanding of how these service requests are getting assigned and are moving through city departments, I want to go look at actually a path analysis, and I'm going to take you into the accounts payable workflow. So remember, this is a different data set. It's going to be this invoice processing, and what I'm showing you here is the path analysis. So when you begin analyzing, starting to map kind of how your process is flowing, the next thing is beginning to analyze what your ROI, when you're looking at Lean or Six Sigma and sort of going in with process owners. This tool is going to allow you to show exactly how the process was completed with the most commonly followed paths here to the left, but then also showing you some of these weird or anomalies that are standing out where it's jumping around and those sorts of things. So what the tool has done here is it's clearly exposed where the most commonly occurring path is here to the left, but then it's clearly exposing where things are being skipped or done repeatedly or totally out of order, with the most common paths highlighted for us. So the tool has suggested these to the left, where we can start to change and filter these at any time, removing some of these or bringing these back in. Aside from that, I'm also presented with the number of timelines. So I can see how many actually follow this unique path, how long it's taking. So the ideal path, 3 days, versus some that are taking 4 days or longer or shorter. I can also see how much this is costing. So when you think of the average cost for a specific process, we can start to see where the ideal process is $6.29, where some are longer at $19, some as many as $32. So that sort of thing here is where when we're looking at a cost efficiency and the different process flows, it's a way to kind of ideally find where those problems are occurring. So what I see here with this second path here, the average cost $19, a lot more than what our ideal path is, but it looks like there's some steps where things are being skipped. So when I think about a compliance problem or just addressing compliance in general, this is something that I may want to drill in on. So I can then apply this as a filter, and this is possibly a costly and even a risky area, and then be able to go into the timelines, be able to drill in on some of these areas, finding out exactly what's going wrong. Obviously, I saw some things there where the processes were being skipped, events were being skipped, and that's a compliance problem. So when you're thinking about time efficiency, cost efficiency, that's a good way to drill in on some of these things. So filtering of the data will become a theme, as you'll see as we go along. So we start with a large data set, and we begin to whittle it down to more manageable sizes. So in certain cases, we'll build in conditions, or sometimes we'll let the tool do an analysis on its own. We're just trying to uncover the weird and wonderful things that are kind of happening within that. So I'm removing my filter very dynamically, bringing back all of the data that's there. And the next process area that I want to bring you into is our time interval measurement tool. So I want you to remember that these could be done with any process, any area that you want to improve upon. Well, what this one is emergency response. Like I said, it's coming from a computer-aided dispatch system. So with this interval measurement tool, we specify 2 events and calculate the time between them. Again, we can drill in and begin to see where there's problems and things that are occurring longer. So I specified here from earlier, the starting event is transport started, and the ending event is arrive at the hospital. Certainly, this is a very critical area in government and in emergency response, and pretty much if I was in an ambulance, I would have hoped that it would take a very short amount of time. So what I'm seeing here is I'm presented with a histogram that displays the number of time that it's taking for this to occur. So I see that the minimum is 2 minutes, and the average is 13 minutes and 15 seconds to arrive at the hospital. But we have cases as long as 2 hours. So 2 hours is a very long time to be in an ambulance going to the hospital. I certainly hope that I'm not in an ambulance that long. But what we can do is begin to drill in on this. So you can see dragging this along here, I'm thinking 30 minutes is a good time. That by that time I expect to be at the hospital. So we see that there's 94% of the cases are arriving at the hospital before the 30 minutes. But of course there's this 6% that's sort of an outlier. When I apply that as a filter and zoom in on the timelines, we're then presented with the 593 cases that are taking longer than 30 minutes. So now I can review them individually, consider the details of a specific case, pop one of those up, or even, say this as a filter. So as I drill through here, saving as a filter to kind of come back and analyze further later. But I want to further be able to break this down by one of those attributes to see if these delays are related to a human element coming from a specific department, a supervisor or chief, or maybe perhaps a neighborhood or certain equipment. So what I want to look at, are there any trends in the data which show us where the delays most commonly occur, or could show me a root cause where there could be a human element that's giving me a problem? That's where I want to bring you to our breakdown tool. What I've done here is I've shown that I'm breaking it down by the event dispatch and the attribute neighborhood. And what I'm seeing is that in Tenderloin, it's responsible for 15% of these longer cases, stands out from some of these other neighborhoods. I can apply that as a filter, further drilling in on that neighborhood, showing you that as we scope this analysis, we're then shown only those 86 cases within that neighborhood out of our total project there. That's nearly 69,000 emergency response claims. So then I want to further scope that, go into actually when that transport started and what unit was assigned to that. I'm then shown that this sort of M03 unit is responsible for 34% of those cases in Tenderloin that are over 30 minutes. Again, can apply that as a filter. So what I'm seeing is I break this down by the specific neighborhood, and we see that Tenderloin is accountable for over 15% of these longer cases. We then drill in and further to see if there's anything more going on. As we can see, the unit M03 is responsible for 34% of these longer transports in Tenderloin. There may be some reason for this, and the next step would sort of be able to drill in on this process instance, see what's happening there. Certainly, there may be some reason for this, and it may be time to have a conversation to see if there's an equipment problem or some type of other issue that could be resolved to improve this transport time and can help to avoid these longer cases or these problems from occurring in the future. Just as quickly as I set these filters, I can remove them or save them for later analysis. I want to bring us back to the query tool in city services. And the reason why I really like the query tool, for me it was a way, coming from city government and looking at how problems are found or hypothesizing about process problem areas. It's generally very difficult. It takes a long time to get reports back about how process is flowing, the efficiencies, where things are being repeated. So when you think about search or query, it's definitely a hugely important area. Traditional BI search looks for objects by using their attributes, sort of those dimensions I've talked about earlier. But what if we need to find things by their history? So what if someone were to ask, how often does this specific thing happen? I'm going to hypothesize an area where an issue isn't reported, but a city service request gets opened, an issue gets found, and then some work gets completed. So it's something that we wouldn't expect to happen. It seems like it probably shouldn't happen. But by only using traditional BI search, we have a very difficult, if not impossible, time answering that question. So in this scenario that I hypothesize, we're thinking that something certainly shouldn't happen. So I want to build out this case here where The issue is reported, as we sort of expect would happen. Case then gets opened. Of course, then the issue is later found, and then we have some work that gets completed. And this is how I sort of expect this to flow. This is the process for getting a city service request to the city government to get it fulfilled, maybe a pothole fixed, a street light fixed, those sorts of things. But like I said, I'm hypothesizing that we have an issue that isn't reported, but a case gets opened and within a specific department. They later find the problem, they have some work completed. So quickly I can search that, begin to see if my hypothesis is true. I see that less than 1%, nearly 114 cases where that's happening. But this doesn't need to be simple. So I can further scope this analysis and be able to drill in further. Let's see where work's being completed more than once. How about an area where there's a specific department, maybe it's the streets department or community life, being able to see exactly where these problems are lying, finding the root cause for cases where we don't think these things would be happening, and I can further very quickly search that. So it doesn't mean that these all happen this way, but it's just saying that these cases here are responsible for 13 of all of these where this is exactly how this is happening. We have that first event, issue reported skipped, case opened, issue found, work completed more than twice, and then we've identified a specific department where those sort of problem areas lie. So you can see this is done very quickly. We can include, like I said, those time constraints, number of repetitions, specific values for the attributes. But I mean, if you really tried to figure all this out with the traditional method, I do truly believe, from my experience, it would take hours upon hours of work. So going through this and seeing that it's very quickly and easy, it's one of my favorite parts of the tool to kind of go off for the ability to explore and test, sort of hypothesize. But another aspect of this is that you can set these up to trigger alerts. So we don't need to babysit the data all day long. We can trigger alerts to fire off when conditions are met, making people aware that these cases are occurring. So when you think of another level of accountability built into the process, showing the ability to actually alert and show the supervisors and managers wherever their problems may be lying, I want to bring our attention to a protocol within our invoice processing system. Along with any process area, when you get into a form of specialized forms of asking questions, we look at protocol analysis. So a good example of protocol is in FSI when someone applies for consumer lending. You have to get certain disclosures and good faith estimates, things that the government require are taken into account. So these are things that are mandated and absolutely have to be done in the prescribed way, or you're in violation of federal law. But likewise, most process areas include areas where when we get to a certain point, there are things that absolutely must happen, and oftentimes in a given time range. So in comparison to the query tool which you just saw, which says give me all the cases that match my conditions, the area here in protocols allows me to define a set of rules which should always be followed and will show the timelines which violate that rule. So in other words, it's sort of the inverse of the query in that it shows the timelines which don't match these rules. So when you think about sort of SLA or timing for our process to be completed, almost every department has goals or a system to say we need to complete tasks and ensure that the job is moving forward in an acceptable time frame. So as opposed to sort of only looking at these data sets here, the way that match what we're searching for, this here is showing us those that don't. So what I have here is that an AP gets received, we have a level 1 approval, some coding happens and paid in an ERP system. What the protocol here is saying that this payment has to be happening within 2 days. So as I show the violations, you start to see exactly the protocol item, what violation type, so whether it's a missing step, it didn't occur within the right amount of time. But I don't want to alert someone with all these sort of false positives. So I begin to hide some of these where I don't think they're important for our supervisor. But aside from just sending a text message or an email alert when these things are happening in near real time, I can also apply this filter to our historical data and begin to see those cases that are there. So as opposed to only looking at the new data that's being loaded, we can also use this for analysis in our historical data. So this is the way that we're showing all the various ways that the protocol has been violated, these nearly 35% of these cases here where that's happening. And then the last thing I want to show you is sort of our dashboard overview. So not your typical dashboard about BI, but more so this is a dashboard that's going to be able to zoom in and drill in on areas where the process areas are needing improvement. So when you think about invoices by vendor, you can drill in on those timelines where only those are happening from a specific vendor. This is a great way to kind of show for an executive or a manager, just give you an overview where you're not sort of going in and analyzing all the timelines, going in and breaking down process instance areas, but showing that you can customize this very easily, drag and drop interface, add new features, sort of those sorts of custom metrics that as a manager you want to be able to see here. But what's the most important about this tool, and I want you to realize, is that I showed you 3 different projects today. The tool is very dynamic in process areas, including just those 3 different event fields and the different fields that we have there, allowing you to kind of scope further with the different dynamics and the attributes that we have there. It can be used with any number of process areas.